All right, my name's Sean Kinney. I'm the editor-in-chief here at RCR Wireless News, and I'm excited to host our discussion today that's going to look at how the technologies we associate with smart buildings, things like connectivity, IoT, distributed compute, and so forth, can serve multiple goals for building owners and occupants, including advancing health and safety protocols that have come up around the coronavirus. To give a bit of context and background, I worked on a report and webinar about 18 months ago that looked at how the combination of 5G, IoT, and AI can deliver a range of smart building use cases that serve to decrease the operating cost for the building owner while simultaneously improving the tenant experience. The thesis of that report was that one investment in technology can, as I said, reduce OpEx while enabling tenant facing amenities that allow building owners to retain and attract lessees at a higher net operating income per square foot. So invest once, cut cost, increase revenues. Fast forward to present, and the coronavirus pandemic has obviously really shaken up the commercial real estate sector as we saw large numbers of workers vacate offices to work from home. And there's still a bit of uncertainty around to what extent we'll see a return to pre-pandemic occupancy levels. But I do think the thesis that I just mentioned still stands, and that those same technologies can do what I mentioned earlier, with the added benefit of making people feel more comfortable occupying buildings. So we're going to explore that today and a lot of other related topics. Some brief housekeeping notes. We are recording this session. It'll be made available on demand on the RCR Wireless News YouTube channel. There's a companion report that will be distributed to registrants, so look for that to hit your inbox soon. And we've reserved some time at the end of our session to take questions from the audience, so please submit those through the webinar portal throughout the presentations, and we'll get to as many of those as we can. So with that, it's a pleasure to introduce our presenters. First up, we're going to hear from Mr. Marco Argentone, Head of Project Management with Telit. Then we'll hear from Mr. Brad Jolly, Senior Applications Engineer with Keysight Technologies. So big thanks to the presenters, a reminder to submit your questions. And with that, I'm going to turn it over to Marco for his presentation.
Hello, everybody. I hope you can hear me well. Thanks for the introduction, Sean. My name is Marco. I'm based in Italy. I work with Telit since more than 10 years, and I'm glad to be here with you today to discuss about this interesting topic that is really becoming relevant, not only for our industries, but also for our daily life, I would say. So you can go to the next slide. And here, let me just kick it off by saying that yes, most of you may have already heard the terms Industry 4.0, IoT, Edge Computing, and Industry 4.0 definitely has been already set a trend in accelerating the adoption of the new technologies in IoT and edge computing in various industries. But let me also say that from my personal perspective and experience, till some time ago, some of these topics and terms were very popular in PowerPoint presentation and a lot of marketing announcements, but not really translated into reality in our lives and in our industries. Now we really see this becoming true, and the fact that you also mentioned, Sean, that the pandemic, that I also put here as one of the catalysts for this evolution, is not just because it's trendy to talk about the COVID situation, right? That we all experienced in the last 18 months already, but because I truly believe that this made a major change in our society. And I intentionally talk about society because it is not just about the topic we discussed today on smart building, but is really related to our houses, our offices, and all the places where we are spending most of our time. And for sure, everybody in this webinar today have experienced the need to stay remote, to be forced to work from home in smart working, or to be anyway isolated compared to what was before our habits and our standards. So we have experienced the need for remote learning, remote shopping, remote everything basically, and probably for the first time in our lives we have understood the relevance and the importance of the technologies that we are nowadays simply expect to work smoothly. And when we have an issue connecting to a server, to a laptop, or whatever else, we feel frustrated because it makes everything really more difficult. And from these little things, we really understand how the world is changing into a new era, in my opinion, where IoT technologies really can play a major role in simplifying the day-to-day activities. And here it comes the topic of organizations that are really looking to automate many aspects of the day-to-day activities and to increase the level of control, and also the security awareness is on the rise. And when we talk about security, often we have an overlap in terms of security and safety at the same time, in the sense that on one side there is the security of the communication, on the other side there is the safety of the people, of the employees, of the people that are in a building, for example. So if you go to the next slide, this is just a graphical representation about some of the topics, not all of them for sure. And also in this case, I have to admit that I was using some of these icons already a few years ago, because when you talk about IoT, it's really natural to talk about the possibility to operate remotely your HVAC system, or the lighting, or the thermal control of the temperature control of the rooms of a building, and so on. But with this new scenario, there are additional aspects that are becoming relevant. And here we just put, for example, an icon about hygiene and cleaning management, because you know how important it was in the last year, but also space management, because, for example, you need to understand how many people you have in a space, which is the occupancy rate of a building and stuff like that. Of course, security I already mentioned, and I will spend a few words later on. And environmental monitoring is also another aspect to take into consideration. Let's say that building managers and real estate investors aren't the only ones who have vested interest in reducing building operational costs and improve the related efficiencies. Any business owner or operator looking to reduce the amount of money spent on utilities and maintenance costs can really profit from employing Internet of Things based platforms to transform their properties into smart buildings. And this is what really we are trying to analyze today and to cover with this short presentation. And when it comes to technologies, if you can please go to the next slide. This is just a representation that I wanted to use with regards to specifically the cellular technologies. I will spend a few words later also on other wireless technology when it comes to IoT, but in this case I intentionally speak about cellular. And there is a distinction that we can make between what is the lower end part of the chart, that it deals with cellular technology that goes from LTE category 1 and below down to LTE category M, or narrowband IoT, for example. And these are technologies that are really suitable for all the sensors, for example, that you can have in your smart buildings, because they can be battery powered, and these are technologies that are really suitable to optimize the power consumption of those devices. And by the way, I just realized, and I apologize for that, there is a typo on the yellow arrow on the left hand side. For sure, power saving is important going down, but the latency times actually it is increasing, while latency times are decreasing for the upper part of the chart, where we go also up with the data speeds. And in this case, we can talk about all the technologies that allow for higher data throughput, for example, and this is why we can associate, in this case, technologies that goes from LTE category 4 and above up to 5G, that is now becoming really the trending topic. And as you can understand from the icons, and I will come back on this in a few minutes, these are all suitable technologies for application where you need to stream data or also video, or anyway use applications that are somehow the collectors and the hubs of all the other data that you can collect with the devices on the lower side of the slide, right? So this is really a complementary let's say technology, and it gives you graphically the understanding that with the integration of both the technologies, you can really cover a lot of the use cases that can become relevant in a smart building architecture. You can continue on the next slide, where without the ambition of being exhaustive, of course, I try also to tell something about the verticals, because when it comes to all these technologies, in the past, let me say that there was no really the ability to differentiate, in the sense that for those of you that have experienced the beginning of the IoT, when it was still called machine to machine, for example, and we started with 2G and 3G devices, in most of the cases, the devices were more or less similar, and the use was just integration of a modem just to transfer data, right? But with this differentiation of technologies that I just presented, and with the additional features that a company like Telit can put on top of the devices that we design and produce, we are definitely able now to characterize the different devices in order to address different verticals. And when it comes to the topic that we are discussing today, we really can see how you could have, for example, a device that is tailored for connected remote temperature and energy management, or you can have another device that instead is suitable for wearable devices, either for generic healthcare applications or to track and trace, for example. And in this case, I'm talking about those low power devices that I was somehow addressing in the previous slide, or when it comes to surveillance requirement, for example, or to monitor the occupancy rates, maybe you need some other type of technologies where instead with more throughput, you can serve for those use cases. So it's really possible now to have this kind of differentiations into different verticals. You can continue, Sean, on the next slide, and remaining on the smart building considerations. This is just a list that we don't have to answer today. To all the questions, but it's more like a track list for you that are listening, because if you are interested into, for example, setting up an architecture for your own smart building ecosystem, for example, there are several topics that you should consider. And depending on which is the use case, depending on which is the problem you need to solve, there might be different answers. And part of my role, and together with the help of all my colleagues here at Telit, we really see a value not just in designing the product and producing the devices, but really to act as a trusted advisor that can guide you through the optimal choices for your own ecosystem, for your own application, for your own infrastructure. And therefore, you may have a need to cover a communication, a wireless communication, for example, inside the building or outside the building, or from point to point, to instead the need of creating your own network. You may have a need to operate into a private network, or you need to access to the public network, for example, if we talk about cellular technology. And then, of course, you have to consider the development costs that are not just related to the cost of the device, but the cost of the engineering that it takes to build up your system, and the testing, and maybe the certifications that you need to go through. And so we really can help you on going through all these topics in order to make the perfect choice. And the perfect choice is not necessarily the most expensive, because it is the device with the highest computational power, and that is allowing you to do a lot of different stuff. But maybe the perfect fit is the lower cost device for a battery life operated device, or maybe you need to combine cellular with other technologies. And I will spend a few words about this as well. So really, keep in mind this list of questions when it comes to smart building considerations, because if we are able together to answer to all these questions, for sure we will come up with a solution that will make your smart building idea becoming a reality, let's say. You can go to the next slide, sorry. And since we have now discussed about different technologies and different verticals, I come back in a way to a different representation of the previous slides at the beginning, by listing explicitly some of those verticals and applications, to show you how they could fit perfectly in association to different cellular technologies. I just circled a couple of examples, since we are talking about smart buildings. So on the lower end side, as I said, devices that are low power, and in most of the cases, probably we are talking about sensors, for example. And on the upper side of this chart, everything that is related to throughput. As I said before, video surveillance, routers, gateways, all the hubs that you need to put together in order to transmit a lot of data, a big amount of data, after collecting the information from the edge. Then, of course, there are a lot of other verticals and applications in between, and then depending case by case, some of them could be relevant to this topic as well. There is no ambition here to have a perfect matching and just representing them into silos. Then, of course, in reality, there will always be an overlap of different aspects. You can go ahead, Sean. And probably there is an animation, additional click. Yeah, and this is something that I was addressing before. Why I'm telling you a lot about cellular, not only because, of course, it's the core business of Telit, but in reality, in Telit, we have a portfolio of devices that are covering also other wireless technology. But since we discussed about security, well, cellular is on the forefront of security standards and protocol implementation. So If you combine this plus the additional features that we are putting on top of our devices, such as a secure boot or other features that are improving and increasing the security of the communication by using our modules, you understand how important this is. And I know that that Brad later on will address also some of the topics related to security as well, because often when you address an IoT ecosystem, you don't take all those considerations into account. But if at the beginning we talked about the pandemic, let me say that there are a lot of other viruses in a way, or anyway threats that we have to take into account when we put all our personal information and our data into a network. That's why it's so important to always keep security in mind when talking about smart building as we are talking today, but more in general about IoT ecosystems. You can you can go ahead, and this is a real quick, just a graphical representation of what we already said. And basically, in IoT, you really can enable a smart building solution covering different aspects from facilities management to utilities management, monitoring, security, wellness, smart applications in general. But what is more important, in my opinion, is to go to the next slide, because if you remember at the beginning, I was mentioning a hybrid approach, and by hybrid approach, I mean that yes, so far I discussed mainly about cellular technology. But as a matter of fact, in our portfolio, we have a complete range of devices that goes from the low-end LTE to the 5G technologies. But we have also devices for positioning that, in some cases, also for smart buildings, also for static applications, may be relevant with technologies like GPS or GNSS in general, and complementary technologies like Wi-Fi and Bluetooth that, depending on the use cases, could be really relevant. And also in this case, let me spend a few words anticipating a bit what you will hear by my friend Brad later on, that will address something about coexistence between different technologies into a building, right? So you can have your Wi-Fi network to collect data or to transmit information inside the building, and then you could have a hub to collect all those data and upload everything to the cloud, for example, and therefore getting access to the main public network via cellular connectivity with high throughput. And then with one edge, just to put an umbrella to all of this, and you can go to the next slide, that is my last one. This is just a representation of what we call the end-to-end ecosystem. Because, as I said, think about a smart building. You have devices at the edge. You have probably a concentrator, a hub, a gateway to transmit data to the cloud. And therefore, in order to enable this end-to-end communication, we need devices. And in our cases, we do modules that can be integrated into the final device and application. Then you need connectivity when it comes to cellular communication, of course, SIM cards and stuff. And then you need one important piece that is the glue of all this ecosystem. That is basically a software layer for everything that, in one word, I could put under the term of device management, right? And therefore, you will realize that when talking about this automation of smart buildings, for example, at the end, you need to control all the data that you are letting flow through your architecture. And therefore, you need really to have a good system of device management, centralizing all the information and managing all the information. And this is what we put under the umbrella of One Edge, that is really our offering for device management. And once again, with a key aspect to take into account, that is the end-to-end security of the information. So having said that, I think this was my last slide. I hope to have respected timing, and I hand over back to you, Sean.
Thanks very much for the presentation, Marco. A reminder to our audience to please submit any questions that you have during the presentation. We'll get to those following the next presentation from Mr. Brad Jolly.
Thank you, Sean. My name is Brad Jolly, and I'm a Senior Applications Engineer here at Keysight Technologies. I'm very honored to have been invited to participate with RCR Wireless and Telit today, and I really enjoyed Marco's presentation, and I thank you all for being here. Like Marco, at Keysight, we're also seeing this move into mission-critical applications, and existing applications such as smart buildings are in fact becoming more critical. Marco and Sean recognize that we really are in a new era, and the trend is likely to continue as the emergence of new technologies enables increasingly powerful and challenging applications with things like 5G and AR and AI. Three particularly obvious examples of the mission-critical IoT that we're seeing at Keysight include public safety and emergency response, connected and implanted medical devices, and connected vehicles, right? Those are obvious big ones. But today's topic is about the mission-critical nature of smart buildings, and we're absolutely seeing those vertical trend shifts that Marco mentioned. One of them is certainly around tenant safety, where you're talking about things like air and water contamination detection, gas leak detection, cleaning management, moisture and hazard detection to prevent slips and falls, crowding and overload detection, and structural stress sensing, especially in older buildings. And we're seeing some sensors that use a property called magnetoelasticity that can measure structural stress. A second reason that smart buildings are becoming more critical is around the physical environment. In one sense, it's sort of a basic expectation, but if you don't get it right, you may actually render your building legally uninhabitable and suffer severe legal consequences. But if you do get it right, the tenants will notice and appreciate the comfort, the energy efficiency, the reliability of the HVAC system, and the air and water quality. A third area reflecting the mission-critical nature of smart buildings is security. And there's a lot of levels to this. So of course, there's the tenant's personal security, the ability to provide the tenant with safety alerts, whether it's related to crime or weather or what have you. The tenant's personal cybersecurity, right? If you've got a building that allows people to hack into your tenants on the Wi-Fi, that's not going to be a good situation. Parking security is obviously a big deal, just general building security. And then the building management's cybersecurity, because sometimes if a hacker can get into the building management system, they will often be able to extract information about the tenants, and then you as the building owner get to explain to the tenants why all that information has leaked through your system. And so regardless of the vertical market, at Keysight, we see our customers dealing with 6 different types of challenges that we call the 5 C's plus 1 C of the IoT. And I'll talk at the end about why we don't just call it the 6 C's. But here are the 5 C's plus 1 C. They are connectivity, compliance, coexistence, continuity, cybersecurity, and customer experience. And I've got just 2 or 3 slides on each one just to explain what we mean by each one of these. And so we'll start with connectivity. And that's, of course, about reliable connections the first time, every time, including roaming and handoffs. And for smart buildings, what that means is reliable data flow. So if you think about any wireless network, smart buildings or otherwise, connectivity is really the key. And you can think about the diverse needs of the different applications. As Marco mentioned, there is not a situation where one wireless technology is the right answer in every situation, because really no single protocol can handle all of these. And so if you look at the more common radio technologies that are used in the IoT, here's a list of 10, 12, 15 of them. And really, there's a lot of challenges that you have regardless of which one you pick. Number one is keeping pace with the evolving formats. So for example, Bluetooth started out in the late 90s, and it's up to, I think, about 15 different versions right now. And you have to keep track of all that. You've got to reduce the time to market because the IoT is a very competitive space. And then you also have to reduce your test cost while still getting robust test coverage. The second C is compliance. And there's a lot to comply with here, right? You've got the legal and regulatory standards. You've got to conform to your industry standards. And then in terms of smart buildings, what this enables is it enables you to avoid recalls and the disruption that it brings to tenants. You can just imagine a situation where you have to tell all your tenants that a particular system is going to be down, or that you may have to come into their space to fix things. So compliance is really a big deal. And around the world, it's a very complex regulatory environment. One of my colleagues, Janet, put this slide together, and it took quite a bit of time, right, to research all of the different standards. And this is by no means all of them. There's a ton of different standards. And what really makes it hard is you have to comply where the device is sold, not just where you are as a manufacturer. And you can just imagine the challenge in making sure you comply with all these different standards. And so a common source of standards is what we call ETSI in Europe. And to them, compliance used to be about spectral purity, right? How clean is your signal? But now it's gone way beyond that, and they expect you to really focus on effective and efficient use of the spectrum. And that's difficult because the 2.4 gigahertz ISM band is really getting crowded and challenging. And so if you think about what a solution might look like, a lot of companies will get a system to do internal pre-compliance testing that involves, signal generators, signal analyzers, MIMO units, signal conditioner, and so forth. But it can really be complicated to try to create your own solution, even with all that technology. So what you really need is a whole solution and not just the instruments. So the third C is coexistence, and Marco mentioned that as well. And the benefit here in smart building tenants, for smart building tenants, is the harmonious flow of data, because interference can happen anywhere. And this picture on the next slide was taken by a colleague of mine in his home. And he was using a Wi-Fi router to stream video to his laptop. And then the laptop was streaming audio to his Bluetooth low energy speakers. And you can see where the audio and video actually are breaking up. And this is just two devices in one room of a suburban home. Okay, this is not a large building with lots of different smart building devices or a crowded common area. And so part of the problem is that unlicensed spectrum, because it's inexpensive to use and because it's unlicensed, it's extremely popular, but it is in fact a limited resource. And so here's what some of the customers have been telling us. And these happen to be from medical and healthcare customers, but really the same principles will apply. One wireless IT manager said he just doesn't even expect a new wireless medical device to work without having to do a lot of work. And you really have to make sure you're testing them in the appropriate context, whether it's medical or smart building or any other vertical challenge. The fourth C is continuity, which is the ability of the device to operate continuously over time. And so for smart buildings, that typically talks about long battery life and sensors, especially in locations that are hard to get wall power to, or during emergency situations where you really need the intelligence from the IoT devices, but the power is out or reduced. And so one of the key problems that we're seeing is that IoT devices have extremely dynamic waveforms that are hard to measure. They've got these very long, low current sleep modes, and then these sudden fast transients that take you from nanoamps or microamps suddenly up to milliamps or hundreds of milliamps. And this range changing can cause glitches that lose data. So you really need a device that has what we call seamless ranging. And there's a variety of things that people have used over time. DMMs, digital multimeters. Sometimes people use their power supplies to measure the power consumed by a device. Oscilloscopes are very popular. And all of these have their pros and cons, and you really have to think carefully when you're choosing the device to measure the current. But accurate current measurement isn't really even enough. You need to be able to relate the waveform to what's going on inside the device. So including things like when the radio turns on or when an encryption processor runs, you need to know exactly which things are consuming the battery and what each event costs in terms of battery life. And so there's a new technique in the industry that's really cool called event-based power analysis. And this allows you to correlate the current waveforms with the RF and DC events going on inside your device. And that lets you see what devices are and what events are draining the battery. So if you look in the lower right-hand corner, you can see how the device is spending its time and its charge. And then you can use that information to change either your hardware configuration or your firmware programming. The fifth C is cybersecurity, and Marco also mentioned that. And boy, this is becoming a bigger and bigger issue. You hear a lot about it in the news these days, and it seems like the rate at which these things are occurring is increasing, and also the cost of the various events is certainly increasing. This might affect the tenant directly, right, if their information is compromised, or it may affect them indirectly through the building owner. But either way, it's something you absolutely have to make sure that you get right in a smart building application. And so it's always been a big deal in computers, but especially in the IoT for several reasons. Number one, the IoT is relatively new. Number two, there's this huge surface area to attack. You've got a heterogeneous set of devices and operating environments. And here are some of the statistics that indicate really how bad the problem is. And the one that scares me the most is the one that says 98% of all IoT device traffic is unencrypted. Boy, that's a tempting target for cyber criminals. And so there is good news though, and that is that there's a strong, what we call ROSI, or return on security investment. And that is that if you can start testing sooner and find defects quicker, it's only about $80 per issue to find and fix something during development. But if you find and fix it during production, it's 90 to 100 times as expensive. And you need to really make sure that therefore you're testing early on. And there's also more good news, and that is that there's a group called OHWASP, and they've put together a list of the top 10 vulnerability areas. And they've really done a lot of work, and it's well understood. And all of these things are preventable by the manufacturer. Now, that doesn't mean it's easy necessarily, but it does say that you really need to start thinking about and testing security in the earliest phases of the project and throughout the life cycle, even through the obsolescence and disposal phase, because sometimes devices that are being discarded will contain sensitive information. And then finally, we get to the sixth C, or the 5C plus 1C, which is customer experience. And the reason we separate this is that all of the others are electronic, but this one is the one that most directly affects the user perception. And so statistics really make it clear. Nearly 9 in 10 companies expect that this is going to be where they compete. And 80% rated as a top strategic objective. And 97% of business leaders say that it's critical to business success. And where it's really interesting is what happens if you don't get it right. Well, 95% of us tell other people about their bad experiences, whether it's either through a formal review on some sort of marketing site or just through word of mouth. And so the belief is that customer experience is actually overtaking both price and product as a key differentiator. And so, as Marco said, this really requires end-to-end communication, because it's a huge opportunity to add value and delight tenants. But if you think about an IoT application, they're really complex systems running on multiple hardware platforms and operating systems. So you've got the IoT devices themselves, and then the tenants are looking at the information on a tablet maybe, or a PC or a phone. You've got to deal with all the cloud infrastructure. And so what you used to have is two parts to the testing. You do your hardware testing and your embedded programming test on one system, and you do your software test on another. But now the expectation is that things will be seamless across the platforms, and what Marco called end-to-end. And so at Keysight, we've spent a lot of time thinking about the IoT and developing really differentiated solutions. I know this is sort of an eye chart, but we've got a lot of solutions, and frankly, this is just a small sampling of them around the IoT. So if you just go to keysight.com and just type in IoT, you'll find a lot of interesting solutions that we have. So I'd like to thank you all in the audience for attending. I'd like to thank RCR Wireless and Telit. I've really enjoyed this, and I'm looking forward to answering your questions.
All right. Thank you very much, Brad. That was a great presentation. Now I'll invite you and Marco to turn on your cameras, and we will have a little bit of a Q&A period in the time left in the hour. So first off, Marco, you addressed this in your presentation, but I think it's an important point that I'd like to circle back to. And that's, specifically when we think about a smart building, why cellular as opposed to other wired or wireless technologies that might already be in place within a building environment?
Yes, Sean. Yeah, indeed, I try to address this, and thanks for the opportunity to to make it hopefully a bit more clear. Cellular is an option, is not the option. There are other technologies that, in most of the cases, can be used together depending on the use case, like Wi-Fi, just to mention the main other one that typically is involved when it comes to smart buildings. But I was talking about cellular because of the high level of security that it can bring with regards to compliance of standards and encryption of data that by definition is implemented in the standard itself. And then now that I think about it, I didn't talk about the interoperability being a standard that is adopted at worldwide level. You are sure by definition that all your products are interoperable with the network in a seamless way, because you have really to comply to some rules that are not leaving anything to interpretation, let's put it this way. So interoperability, security, wide selection of different flavors of the technology, because within cellular technology you go from the low end technology for low throughput and low power consumption up to streaming data with 4G high categories to 5G. These overall are, in my opinion, the three main aspects for which cellular is important in a smart building.
All right. And Brad, you shared a slide that showed the interference one of your colleagues experienced in their home. And as you pointed out, that was just a few devices in a suburban home. So it's really hard to even imagine scaling that up to a high-rise office building with hundreds, if not thousands, of occupants and all their devices. So just help us understand, don't wireless protocols have collision avoidance technology built in as part of the standard that the product's based on?
Well, they certainly do, right? So if you think about Wi-Fi or Bluetooth or Zigbee, they all have their own uh, collision avoidance technologies, but that's the problem. They all have their own. And so it's not necessarily the case that Zigbee can work well with Bluetooth or Bluetooth can work well with Wi-Fi. And there's another major problem, and that is that microwave ovens also transmit on 2.4 gigahertz just from the radiation inherent to the oven itself. And obviously a microwave oven doesn't have any way at all to deal with coexistence. And so it's just a source of random and unpredictable and ill-behaved 2.4 gigahertz radiation. So yes, there are collision avoidance mechanisms within the protocols, but across protocols is where it really becomes difficult.
All right. And then Marco, for you, at RCR, we spend a lot of time covering private LTE and 5G deployments that kind of all fit under that umbrella of Industry 4.0 projects that are really focused on deploying sensors, making the most out of the data available to you, and then translating that into driving efficiency. I'm just curious how and when you think we will see private LTE or private 5G expand from gateways to smart building endpoints like HVAC monitors or connected electrical breakers, distribution panels, those types of devices?
Good question. Um, Unfortunately, I don't have a crystal ball, let's say, but I can try to answer. For sure, the let's say private network topic is now becoming a reality. At least in our company, we started to analyze and scout the market and review opportunities already a couple of years ago, but now we really see a momentum. Typically, this is related to utilities in terms of use case, let's say. And for sure, 4G and 5G are the 4G first and 5G is now coming are the technologies that are relevant for this. And then a lot of factory automation, I would say, for these kind of applications. In order to see this becoming a reality also for smart building, I personally think that this will happen once there will be new devices that are compliant to the new 3GPP releases, for example, because this will allow not only a certain type of devices to be available in the market, but also those that are available already today, but also a new set of devices that are embracing also the lower end of applications that I described today, for example, but with 5G. And therefore, cost, for example, is another key factor for people that have decided to invest in their solutions. And once those standards will start to be in place and lower cost devices will be available also for 5G and for IoT use cases, I definitely see this becoming a presence also for applications in the smart building. So I would say a couple of years we should have this as a reality. While now we will see for sure the ramp up of everything that is related to both public and private networks, but more in the range of high throughput and these kind of applications.
And for Brad, one of your C's that you took us through was compliance, and I'd like to get some perspective from you. If I'm the building owner or the building management firm, do I really need to try to manage that complex process of compliance testing on my own, or is it something that I could reasonably just outsource to a test lab and be comfortable with the process?
So as the building manager, you should look for the various compliance markings on the products that you buy, but the building management shouldn't need to actually do much in the way of compliance testing. Really, that's the responsibility of the device vendors, is to make sure that they're complying with the various regulations. So that's really not the problem of the building owner. It's really more uh, the manufacturer of the devices. Now, that being said, they have advantages and options associated with both doing it themselves and outsourcing it. So if they outsource it completely, that's probably the least expensive way to do it. The problem is if you have a difficulty where you don't pass right away, that can really throw a monkey wrench into your project schedule. And so a lot of times people will do the compliance outsourced, but they'll do pre-compliance testing on their own, which also enables them to get insights over time as to how their devices are improving or not, and that lets them get to market more quickly.
And if I could follow up there, Brad, I'm trying to recall the statistic, but I think that your slide indicated that 98% of the traffic flowing over IoT devices is unencrypted.
Yes.
So, I mean, first, why? Why is that the situation we find ourselves in, and what's the path forward to start chipping away at that number?
Yeah, so as Marco said, as we're moving more into cellular IoT, that number is declining right away, okay, because cellular is inherently encrypted. But a lot of it, if you think about, for example, Bluetooth. Early on, the whole point of Bluetooth was just to connect a couple of local devices, and over a short distance. And the analogy I would use would be kind of like the early days of PCs. When we thought of the early days of personal computers, you had an actual floppy disk that you had to put inside the system, right, to boot up and so forth. And people weren't envisioning huge networks of thousands and thousands of PCs. And so the early days of DOS computing really didn't have much in the way of cybersecurity. And over time, of course, it's had to evolve. Well, the same thing's true with IoT. A lot of IoT applications were designed to be personal by nature, or perhaps research-oriented by nature, where people are thinking, well, who cares if stream flow rates get hacked? Who cares if temperature sensors get hacked on an outdoor temperature, right? And so there wasn't much forethought around the need for cybersecurity. But as we're moving into these more mission critical situations, we're starting to see more and more data needing to be encrypted. And as Marco points out, with 5G and cellular, that's going to happen automatically.
We've got a question here from Gerhard Tan, so thank you for submitting that. This is kind of a two-part question, so I'm going to take this first part, pose it to you, Marco, then the second part maybe we can all discuss. But the first part of this question is, what are the key considerations for marketing IoT solutions?
I take this one, okay. I try to answer. I'm not sure that I exactly understand the question, but I try to give my interpretation in the sense that probably today I just discussed about technology, but there is another aspect that is key when you have to choose which kind of implementation to adopt and how to market an IoT solution. And this is really driven by cost at the end of the day, right? So in the key considerations, I would definitely put costs, and not just the cost of the device itself, but the total cost of ownership. And when it comes to, for example, cellular connectivity, a part of this cost that is, by the way, recurrent is related to the to the data plans that you need to subscribe in order to sustain your devices in the field, always operational and live. So this is for sure one of the aspects. I don't know if the question was going in this direction, but this is the first answer that I feel that I should give into this context.
All right, then here's the second part of this question from Gerhard that I'll throw to the group. But how will operators enable a high impact IoT solution? I guess from my perspective, for what it's worth, the operator has the network, they have the sales relationship. So to effectively sell IoT, it's going to come down to making the right ecosystem partnerships, and then sort of reorienting your sales process to not lead with technology, but to lead with what the business outcome is. And then you also need to be able to speak the language of the buyer in each of these verticals, whether that's mining, manufacturing, or commercial real estate. But that's my observation on the market. Brad, I know Keysight engaged with operators all over the world. What are some of your thoughts around how operators effectively monetize their IoT offerings?
I think the number one thing is simplicity. I think that we've talked a lot about technology today, and that's very, very important. But at the end of the day, customers really don't want to know all about that, nor do they want to have to know about that, right? Again, thinking back in the olden days, there was this idea that telephones themselves were too complicated for people to use. And so you'd pick up your party line phone and talk to an operator, and the operator would then place the call for you. Well, now we make phone calls and don't even think about the underlying complexity. And I think we're going to have to see a similar thing with the operators. I think that they're just going to have to provide value that's simple and it works, and the end user shouldn't have to think about all of the underlying complexity.
Any thoughts on that, Marco, on how operators can more effectively get their IoT solutions to work for these different verticals in a way that is affordable, simple, but also delivers on the desired business outcome?
Well, I was, for example, talking about the data plans, and what I started to notice already a few years ago, but probably not yet a reality because of the need to have networks for the adoption of those technologies. But when the IoT ecosystem started to become familiar with IoT technologies such as CAT-M or narrowband IoT, for example, one of the key points in order to facilitate the adoption also for applications that were not natively even designed for connectivity was to change the paradigm of the data plans that I was mentioning before. So you don't have to pay for the data that you transmit, because at the end of the day, for the low-end devices, you actually don't transmit for the most of the time, for example, but you pay for the service that you get, right? So I think that a good activity by the operators from this perspective could really help to ease and facilitate the message and the understanding by the adopters on how those new technologies could simplify their use cases and their implementations. Of course, there should be a good trade-off between the profit that the operators have to make around it and the advantage that the users can benefit by choosing this kind of technologies, for sure.
Right. Well, we're at the end of our session, but I'd like to get to two more questions. So we're going to run slightly long for everyone in the audience. Appreciate you sticking with us. But Brad, I was just curious to get some outlook for you around energy harvesting. We obviously talked a lot today about the importance of battery life and the ability to monitor battery life in an IoT device. But what's the outlook for energy harvesting? Is this going to be viable long term?
I think it will. I think we're starting to see, for example, light switches that can use the mechanical energy and harvest it via the piezoelectric effect to do microcharging of a capacitor, for example. And so, yeah, I think that's one example. Another is around thermals and microthermals for things relating to the human body. You can actually use the gradient between the skin warmth and the outside surrounding air to harvest little bits of energy. And I've actually even seen little tiny windmills, micro windmills, 3D printed on computer chips. So we're talking obviously extremely small windmills, but they can actually provide enough power to recharge a capacitor that can keep a chip going for a long period of time. So I think there's a huge upside to energy harvesting. Will it replace batteries? No, because the other trend that we're seeing is the power demands of these devices as expectations increase. The power demands are also increasing. And so while the energy harvesting is going to handle the low end, we're seeing growth in the high end that so far is still requiring batteries.
All right, and sticking with this this power theme, Marco, we'll end with you. Why is low power so important in the context of a smart building, given that grid power is going to be accessible?
Well, in this case, allow me to use the simplest answer that often is the most true in a way. For the simple reason, for example, that you can place a battery-powered device everywhere. You don't have to drill the wall on break walls to just plug into the mains, right? Of course, if you have, let's imagine the standard use cases that everybody knows in IoT, such as smart metering, for example, that for sure is also fitting perfectly in the smart building scenario. If you have an electric meter, of course, you leverage the power that you have there, right? So you don't care about power consumption. You can put whatever device you want. But if you have a gas meter, if you have a water meter, you have to put a battery power device. So power is important. If you need to put a sensor in a room where in a position where you don't have the grid power available, a battery power device is also suitable. And again, I hope not to repeat much myself, but cost is important. So a complex device with all the power circuitry and so on is probably more costly than a simple battery powered device and miniaturized device also. Let's not forget that. There is a trend of the technology, in particular with the new standards, that allows really miniaturization. And sometimes it's a marketing aspect. Also in the IoT industry, the smaller is nicer in a way, but also there are some aspects related to the overall cost of the solution. So in general, I would say that these two topics could answer most of the cases. For sure, there are other good reasons, but the first two that comes to my mind are those.
All right. Well, I think we're out of time for today. To everybody that joined the webinar, thank you for taking the time. And Marco and Brad, I really enjoyed your presentations and appreciate you participating in this Q&A to share your perspectives. So thank you.
Thank you, Sean.
Thank you for having us.